Today we're going to look at 45, 45, 90 triangles. So in the warm-up it says, using what you know about right isosceles triangles, solve for x, y, and z. So maybe from geometry you might remember that if you see this box in the corner, it means this angle is 90 degrees. And if you see that these two lines right here, it means that these two sides are congruent or equal. So if this side's 72, this side is also 72. There are 180 degrees in a triangle, and if it's isosceles, the base angles are the same. So this angle equals this angle. So in a triangle, we have 180 degrees. We know that that one corner is 90, so that means there's 90 degrees left to spread between two angles that are the same. So each angle will be half of 90, which is 45. So z is 45 degrees. X is 72 centimeters. And you can use Pythagorean theorem to figure out y right here. So we could do 72 squared plus 72 squared equals c squared, and we could solve. So I'll pop up my calculator here and type that in. All right, so if we type this in here, so we have 72 squared plus 72 squared, and then we're going to take the square root of that. So that side, it should be the longest side, and it is about 101.8 centimeters. So before the investigation, and today we're going to look at this type of triangle and look for shortcuts for solving. So before the investigation, we have to remember how to simplify square roots. So the square root of 1 means what number times itself is 1, and that would be 1. What number times itself is 4, and that would be 2. What number times itself would be 9, that would be 3. And what number times itself would be 16, and that would be 4. How about this one, the square root of 8? So this one we thought, what's the biggest square number we could divide 8 by? And that happens to be 4. 4 times 2 is 8. The square root of 4 is 2. So this is 2 square root of 2. The square root of 12, what's the biggest square number we can divide 12 by? Again, it's 4. It's 4 times 3. The square root of 4 is 2. So this is 2 square root of 3. And the square root of 20, again, it's 4. 4 square root of 5. And we have 2 square root of 5 is the simplified square root of 20. How about 18? Well, we can multiply 9 times 2. 9 is a square number, and we get 3 square root of 2. 27 is 9 square root of 9 square root of 3, which is 3 square root of 3. And 45 is square root of 9 times square root of 5, which is 3 square root of 5. So we're going to use what we know about simplifying square roots and do a little investigation here. Use what you know about isosceles right triangles to find the missing sides of each triangle. Look for any pattern. Okay, so this side right here, again, the sides, this is half a square, so the two sides are the same. The hypotenuse will use Pythagorean theorem. 1 squared plus 2 squared equals the hypotenuse squared. Oops, that should be 1 squared, not 2 squared. So a squared plus b squared equals c squared. 1 squared is 1. 1 plus 1 is 2. We take the square root. So this guy is the square root of 2. Let's try the next one. 2 squared plus 2 squared equals c squared. 2 squared is 4. 4 plus 4 is 8. 8 equals c squared. We'll take the square root of that. Let's simplify the square root. This is the same as square root of 4 square root of 2. And that equals 2 square root of 2. So this is 2 square root of 2. Let's try this last one over here. So we have 3 squared plus 3 squared equals c squared. 9 plus 9 is 18. 18 equals c squared. Take the square root. This is the same as square root of 9 square root of 2. And then the square root of 9 is 3. So this is 3 square root of 2. So take a look at these sides and notice that if the sides of the triangle are 1 and 1, the hypotenuse is 1 square root of 2. So 1 right here. If the sides of the triangle are 2, this is 2 square root of 2. If the sides of the triangle are 3, this is 3 square root of 2. And you could probably make a prediction what's going to happen with these triangles. I'm going to write it out. So this will be 4. This will be 4 square root of 2. This is a 5 times 5. Or not 5 times 5, but the sides are 5. And this will be 5 square root of 2. And if this is x, this will be x squared of 2. So in a 45, 45, 90 triangle, this is the shortcut. Instead of using Pythagorean theorem, if these sides are n, this side will just be n square root of 2. And again, this is a 45, 45, 90 triangle, or half of a square. So again, half of a square right here. All right, so today you'll be asked to solve for two things, a leg and the hypotenuse. So we're just going to go over how you would solve them. And then your assignment will be to finish a similar worksheet. So first of all, we have the two legs. So B is 24, and A will be 24 square root of 2. And again, we want to know it's a 45, 45, 90 triangle if two sides of the triangle are the same, and the angle between them is 90. So here's another 45, 45, 90 triangle. It asks you to solve for A and B. So let's just make one A and one B here. So we're going to say that the side A is 17, and the side B, the hypotenuse, is 17 square root of 2. And again, if the sides are the same, 12, hypotenuse is 12 square root of 2. Okay, so if I give you a leg, it's pretty easy. The other leg's the same, and the hypotenuse is the leg times the square root of 2. All right, now if I give you the hypotenuse, again, if I drop my triangle right here, these sides are the same, so this is n square root of 2. So right here, we have the hypotenuse, 7 square root of 2 equals n square root of 2. So we can very clearly see that n equals square root of 7. So both these sides are 7. Same thing right here, we have 3 square root of 2 equals n square root of 2. So these two sides are equal right here. And again, if we cancel the square root of 2's, n is 3. And then the last one, these sides have to be 24. And the hypotenuse will be 24 square root of 2. All right, what if the hypotenuse doesn't have a square root of 2? Well, again, we look at our equation right here, our triangle. These are n. This is n square root of 2. So right here, you ask yourself, what two sides are we looking at here? Am I looking at n or n squared root of 2? And here, 14 equals n squared root of 2. So here we just got to divide by square root of 2. So n, the two smaller sides, are 14 over the square root of 2. And we'll leave it like this. There is a way to simplify this radical more, but we'll leave it like this today. Same thing here, the 12 equals n squared root of 2. So we'll divide by square root of 2. These cancel. And these sides are 12 over square root of 2. The last one, we have 7 equals n squared root of 2. Divide by square root of 2. So n equals 7 over square root of 2. Okay, so we looked at using that triangle to solve for different sides. And so we'll practice that today, and also we'll practice tomorrow in class. So if you have any questions, let me know, and we'll cover it tomorrow in class.